All right, welcome back everyone. I am your host Shane Furs. This is the third instructional video for Soils or Forestry 2505, Soils for Plant Growth. So what we've done so far is we've located where our transect is going to be. We've dug a soil pit at the crest of our transect. We've identified our soil forming factors. We've dug our pit. We've analyzed our horizons in terms of classifying our forest floor mineral horizons. We've identified or measured the depths of our horizons and where they occur within our profile. We've discussed our coarse fragments, our surface stoniness, rockiness, and this video is going to cover the last measurements that we need. So what we're going to do is we have our horizons and our depths. We're going to determine some of the physical properties of our soils, namely our soil texture, structure, boundaries, coarse fragment contents, modeling if present. We are going to talk about our soil classification, so classifying our soil profile based on the Canadian system of soil classification. We're going to determine our soil drainage based on our physical properties and where we are on the slope. We're going to determine our vegetation type and soil type, and these are important in filling out an edaphic grid, and we'll discuss that in further detail shortly. So to begin, we're going to look at soil texture. And soil texture is simply determined based on one of our horizons. So say we use our BF horizon, we take some of our sample, try to get the roots and things out, lay our sample in our hand, and here we want a bit of water. And we're going to moisten the soil with water. If you put too much water, add a bit more soil. And the soil test, or the texture test in our lab manual is on page 23 to 28. "24 is your texture triangle, 25 and 26 is the test. So we start with the moist cast test. And what we do is we simply crunch some in our hands and we see how well it holds together. The more durable it is, and when we toss it back and forth, the more clay it has in it. We can see that the cast I produced, it's not falling apart as I toss it back and forth, which means there's a fair amount of clay in the soil. Next, we simply roll it between our thumb and our hands to try to make a ribbon. And we see as it comes out of our hand, does it fall apart or does it form a ribbon? And we see it falls apart into pretty much nothing as we try to form a ribbon. So based on the cast, I would say it has a weak cast. In terms of ribbon, it flakes. So it doesn't form a ribbon at all, it just flakes. Based on that, we're dealing with a silt loam soil texture. So our BF horizon, we would give it a silt loam. Next on the list, we have our structure. Structure is determined based on distinctness, size, and shape. When we want to determine soil structure, never use a sample from your profile because we've already broken the structure apart. So coming back to our BF horizon, we simply jam the trowel into the side and pop some sample out. And we take a piece, and this is the structure of the soil. The structure is the aggregation or the PED that forms from the binding of individual soil minerals and particles. So this is our structure, and you can see that roots and other things help hold the structure together, or the PED together. With soil structure, it is on page 29 to 32 of your lab manual. And with structure, we look at the distinctness. So that's pretty much how does it hold together, what's the shape of it, what's the size of it. So if it holds together when we pull it out, you can see here most of it fell apart, so it's actually quite weak. So we say it's a weak structure. Now next we hold it up to our lab manual and we look at the edges of it. Is it rounded? Is it sharp edges? Well, it's quite rounded, so we know we're dealing with a subangular blocky structure. And we hold it up to determine the size. So you simply hold it to, see, it just fell apart, so it's quite weak. But based on the size of it, I would put it in the fine to medium. So our structure for our BF would be a weak, fine to medium subangular blocky structure. So it's pretty straightforward in how to fill these out. It does take some time to get used to this. Our consistence is the soil's resistance to penetrability. So if we have some structure in our hand, how well does it hold together? Our options are loose, which means it has no structure, it's all individual particles. Friable means it holds together, but as soon as you put any pressure, it falls apart. Firm is it takes quite a bit of pressure between your thumb and your finger to break the aggregate. And very firm is it takes even more pressure. And compact, which means you can't break it even with your own body weight. So here we have a very friable consistency because it all falls apart the second you take it out. Next are our boundaries. Our boundaries are the boundary between our horizons. And we look at this boundary and we decide, is it go all the way around our profile or is it broken? Broken means it's not consistent all the way around. Now it can be difficult to determine that when you have such large surface stones. With boundary, we also look at the topography. Is it a straight line that breaks apart our horizons? Is it wavy? Is it irregular? Or is it broken? It's inconsistent. Here, our boundaries tend to be pretty wavy. They're not straight across. So if you look in your lab manual on page 36, we have abrupt, clear, gradual, diffuse, depends on how wide they are, and then smooth, wavy, irregular, and broken. Smooth, wavy, irregular, and then broken is they're not continuous. So using that, we identify our boundaries within our profile. We do the same thing for roots. Roots you really need to be in the pit to identify. It's pretty straightforward. And we also have our coarse fragment content. Coarse fragment content are similar to roots. You look at a boundary, you identify how many coarse fragments are in that area and based on size. So we have gravel, cobble, stone, and boulder. Gravel is our smallest, followed by cobbles. Stones would be this. Boulders are even larger than stones. Boulders are the biggest before we're into full bedrock. So coarse fragments, you look at somewhere in your profile, you can see that these are all rocks in our BF in this area. So based on that, you give it a percentage. So of the boundary, what percentage is occupied by gravel? What percentage is occupied by cobble? What percentage is occupied by stone? And you provide percentages for each coarse fragment size. Models are a result of redox reactions, oxidation reduction reactions, and there tends to be little pockets of soil that are completely different color than the actual matrix around it, which means like the body of the soil. You tend to have little gray pockets in a brown or orange mineral soil, or you tend to have orange pockets in a gray mineral soil. Here we don't have any modeling occurring, so we leave that blank. Our last property that we look at is the color, and simply what we do is we take some soil in our thumb and our finger and we rub it on to create what's known as a color smear. So that way we can identify the color of the soil based on our smear. Once we have our physical properties determined, we want to identify our soil drainage, which is on page 46, page 1 of the lab manual, lab report. So the drainage key is on page 49, and what we do is we simply follow the key to identify our drainage. And we do that, we say, is the forest floor greater or less than 40 centimeters? Where our forest floor is only 3 or 4 centimeters, so no. Is it covered with mottles? No. Is it dominantly gray in color? No. Do coarse fragments occupy greater than 2 millimeters of the space and they're 35%? Or is the texture sandy loam? Or is it a loamy sand texture? No. And then the next is it a clay loam or silt loam texture? Yes. So our drainage as well. So we simply use our key to the best of our abilities based on our soil texture, coarse fragment content, and we come up with a drainage class. When we know our drainage class, we want to determine our soil profile classification based on the Canadian System of Soil Classification. We use this profile, and that is on page 98 to 115, and it's broken into 3 sections. We begin with our subgroup, followed by grape group, and then our order. Orders are the dominant classifications. So if you ever hear the term Podsol, Brunasol, Luvasol, Graysol, Regasol, these are our orders. This gives you an idea of the dominant profile or the dominant physical and chemical processes acting on the profile. So if we say we have a podzol, we know we're dealing with eluviation. A brunasol means everything tends to stay brown in color. There's not much for chemical processes acting on the soils. Glaysol means everything's been so saturated with water, everything's gray in color. So looking at the color we have here, we know we're dealing with a podzol. Podzols are identified based on the eluviation process. So it's that white orange. We know we have a podzol. So we simply go through our booklet until we find our podzols. Page 109. So we know the order is podzol. We then simply determine our subgroup and grade group. And to do that, we look for what's bolded. So, do we have a BH horizon? Well, no, we don't. Do we have a BHF? No, we don't. Do we have a BF? Yes, we do. So we know we're dealing with a great group of humoferric and our order is podzol. So then we look at the dominant horizon outlined in the sequence of horizons, and we say, okay, we know we have an LNF, an AEH, an AE, and a BF. So from that, where we have some H in our AE, but it's still dominantly an AE, we're dealing with an orthic humoferric podzol. So our soil classification, our profile classification would be orthic humoferric podzol. Our forest floor classification is based just on the forest floor component, and you simply use the lab manual. You have more mull and motor, depending on if you have an LF and H or just an LF horizons. And then our last part that we want to cover is our VT and ST for an edaphic grid. The edaphic grid is simply a grid in which we plot, based on our transect, the VT class and the drainage class. And what this will tell us is the overall productivity of the site based on nutrient retention, nutrient richness, and drainage. Is it poorly drained? Is it well drained? We know we're dealing with a well-drained soil, so then we determine our VT. We determine our VT based on the vegetation species around us using a vegetation key in our lab manual. The vegetation key is on page, for mineral soils, is on page 170. And it's just like our drainage key, we simply start and then we identify our vegetation species, which will provide us a VT key. So our dominant vegetation species here is balsam fir. There is some eastern white cedar. For ground vegetation, we have wavy dicranum, some steppe moss, and we have wood fern. So we simply look for these species as we start working our way through the key. And as we go through, we have some beech moss there, which we don't have, sphagnum, yellow fir. We work our way through. This key, you're not going to have all of your species in this key, unfortunately, so you kind of have to pick and choose where they do occur. I highly recommend looking at other vegetation keys that other provinces use. It can help you identify this. Here we have our wood ferns on a high VT. Looking for balsam fir, some of our mosses. We'll be dealing with probably a VT of 8 for this site, just based on where our balsam fir occurs and our wood fern occurs. It puts us in this half of the VT, which is the higher values. So again, the VT isn't always that instructive. It looks at the dominant vegetation species and whatever vegetation you have present to identify your vegetation key. So if we see a VT of 7, we have balsam fir, red maple, and starflower. So we write down our VT number and our VT classification, and we plot that VT point with our drainage on our edaphic grid. So VT7, well drained, we put a plot, we label it, this would be pit number 1. Soil type, our soil classification is on, our soil type classification is on page, bear with me, It's just before our VT. It's on page 173. And again, it's a key. We go through the key. Do we have a forest floor greater than 40 centimeters? No, we don't. Do we have an AP horizon? That means a plowed horizon. So are we in an old farm field? No, we are not. Is our drainage class well or rapid? Yes, it is. Is our texture loamy sand or sand? Or total coarse fragments greater than 90%? No, it's not. Soil derived from granite or felsic volcanic rocks? No, we're dealing with sedimentary rocks. Is it gray in color? Yes, it is, because we're dealing with gray sandstone. We have an ST of 6. So our ST6 gray sandstone, well drained, dry from coarse textured Pennsylvanian sedimentary parent materials. Sea horizon yellowish brown. Yes, we have sedimentary parent material, so we're dealing with an ST of 6. So our VT we said is 7. We provide the name. ST6, we provide the name. We fill out our Adaphic grid. We build on the Adaphic grid each week, and that way you can see how our profiles or our sites change from week to week to week. Are they nutrient rich and well drained? Are they nutrient poor, poorly drained? It gives you an idea of productivity. So based on that, that is pretty much the extent of this video. These sequence of videos will walk you through how we identify our site and how we complete our soil transect or our transect and soil pits for the outdoor lab component of the soils course. For the indoor lab component, we will get into more detail on our physical properties. In the lab, we'll determine soil pH, texture, organic matter content, our nutrient concentrations to build on all of this information. We do that on a horizon by horizon basis. So in the lab, when you have your soil profile dug, myself or TAs will come around, or an instructor will come around, and they will collect soil samples. These soil samples are what we will use in the field or in the lab to identify some of the physical and chemical properties of each horizon. Once that is said and done, we make sure we have all of our tools accounted for, and then we simply fill in our pit. And for that, I would just like to say thank you. Thanks for watching. I hope you find these videos helpful. I'll provide contact information for myself, so if you have any questions, feel free to contact me. And that's all for now. Thanks for watching, and have a good one.